Matrix multiplication. If A is equal to 6, 7, 2, 1, 1, 3, B is minus 4, 2, and C is 2, minus 3, 1, the first matrix has 3 rows, 1, 2, 3, and 2 columns, 1, 2, so that's known as a 3 by 2 matrix. Next one has 2 rows and 1 column, so that's known as a 2 by 1 matrix. And C has 1 row and 3 columns, which is a 1 by 3 matrix. Find, if possible, AB, CA, and CB. So for multiplication of matrices, the number of columns in the first must be equal to the number of rows in the second matrix. AB. Right, the number of columns here is 1, 2, and the number of rows here is 1, 2. Therefore, these are compatible. 2 columns and 2 rows, compatible. Okay, so what we do is the first row times the first column. So we do 6 times minus 4 plus 7 times 2. And then we do the second row times the second column. So times the first column, we've only got 1 column here. So it's 2 times minus 4 plus 1 times 2. And then we do the third row times the first column. So it's 1 times minus 4 and 3 times 2. And then all we do is add those together, multiply and give together. So we get minus 24 plus 14, minus 8 plus 2, minus 4 plus 6, which gives me minus 10, minus 6, and 2. B. Okay, here we have 3 rows, 1, 2, 3, and here we have, sorry, that's 3 columns, and here we have 3 rows, 1, 2, 3. Therefore, these should be compatible. 3 columns in the first, 3 rows in the second, and therefore we have matrices which are compatible. So we do the first row times the first column. So that's 2 times 6 minus 3 times 2 and 1 times 1. And then we do the first row times the second column. We place this one here. 2 times 7 minus 3 times 1, 1 times 3. Then all we need to do is add these up. So it's 12 minus 6 plus 1, 14 minus 3 plus 3, which is just going to give me 714. CB. Right, here we have 1, 2, 3 rows, 3 columns, sorry, and here we have 1, 2 rows. So we have 3 columns and 2 rows, which means these matrices are not compatible when we cannot multiply them together. So CB is not possible as the number of columns in C, the first matrix, is not equal to the number of rows in B, the second matrix.